A species that survived the last ice age is now running a biological experiment it didn't choose, learning to live without the ice it was built for. Welcome to the science of the unexplained. I want to take you on a journey through the vanishing world of the Arctic's apex predator. What we find there is stranger and more contested than anyone expected. In July 2023, a research team with the American Museum of Natural History's Center for Biodiversity and Conservation photographed a polar bear on the coast of Hudson Bay eating a muskox, not fish, not seals. A muskox, a land animal that polar bears had no documented history of hunting. The bear was thin. The sea ice had disappeared 3 weeks earlier than the 1980s average. And the muskox was not a fluke. Biologist Linda Gormasano, who has studied Hudson Bay bears for over a decade, had been documenting this behavioral shift for years. The bears weren't dying, they were changing. Which raises a question that splits the entire field of polar bear research right down the middle. There are currently between 20,000 and 31,000 polar bears alive, distributed across 19 recognized subpopulations from Canada to Russia to Norway. That number comes from the IUCN Polar Bear Specialist Group's 2021 assessment, and the range itself is telling. An 11,000 animal margin of uncertainty is not a rounding error. It is a confession about how little we can observe in one of the most remote environments on Earth.
Of those 19 subpopulations, the 2021 assessment classified 4 as declining, 2 as increasing, 5 as stable, and, crucially, 8 as data deficient. Nearly half of all polar bear populations exist in a statistical shadow. We cannot tell you if they are growing or disappearing.
The subpopulation researchers know best is the Western Hudson Bay Group, approximately 780 to 900 bears, studied continuously since the 1980s by Environment and Climate Change Canada. It has declined by roughly 30% since 1987, according to a 2022 aerial survey conducted by the Government of Nunavut and Environment Canada. That number is contested by some Indigenous Inuit observers in the region, who report more bear sightings near communities than at any point in living memory. Both things could be true, and that contradiction is exactly where the science gets uncomfortable. The Western Hudson Bay bears come ashore every summer when the sea ice melts. They always have. For roughly 4 months, they fast, living off fat reserves built during the winter seal hunting season on the ice. Then the ice returns, and they hunt again. This cycle has governed their biology for tens of thousands of years. The problem is that the ice is returning later and leaving earlier. According to satellite data analyzed by the National Snow and Ice Data Center in Boulder, Colorado, the Hudson Bay sea ice season has shortened by approximately 3 weeks since the 1970s. 3 weeks of fasting added to an already extreme physiological margin. For a pregnant female, that margin may not exist. She needs to gain roughly 200 kilograms before denning. If she cannot, her cubs do not survive. Biologist Andrew Derricher at the University of Alberta has tracked body condition scores in Western Hudson Bay bears for decades. In a 2020 paper published in Global Change Biology, Derricher and colleagues documented that female bears in the population are arriving onshore lighter than they were 25 years ago. Not dramatically, not uniformly, but measurably and consistently. And then there is the Beaufort Sea subpopulation, the one that was supposed to be a bellwether. In 2006, the U.S. Geological Survey estimated roughly 1,500 bears in the southern Beaufort Sea. By 2010, a survey led by USGS wildlife biologist Eric Rode documented a decline to around 900. The cause appeared to be a near-total loss of multi-year sea ice in 2004 and 2005, the ice platform that ringed seal populations depended on for pupping and that bears depended on for hunting. The prey collapsed first, the bears followed. But here is what that story does not tell you. 600 kilometers to the northwest, in the Chukchi Sea, a different subpopulation of polar bears was doing something unexpected. The Chukchi sea bears should have declined. By every model available in 2010, they were projected to. Their sea ice was disappearing at rates comparable to the Beaufort. Their prey base faced the same pressures, and yet a 2018 study published in Scientific Reports, led by USGS researcher Karin Rode, found that Chukchi bears were in better body condition than their Beaufort counterparts and had maintained stable reproductive rates. Rhodes' team tracked 30 female bears over multiple years using GPS collars and body condition indices. The data was not ambiguous. Something in the Chukchi system was buffering the bears against ice loss, at least for now. The leading hypothesis involves prey density. The Chukchi Sea is among the most biologically productive Arctic waters, and bearded seals there remain relatively abundant. But Rode herself has been careful not to call this a solution. In a 2021 interview with the journal Science, she described it as a temporary window, one that may close as ice loss accelerates past a threshold the current prey base cannot absorb. This is where the field's deepest disagreement lives, not in the data, in what the data means over time. Geographer Susan Crockfur, affiliated with the University of Victoria, has argued publicly, most recently in her 2019 book, The Polar Bear Catastrophe That Never Happened, that polar bear populations are more resilient than mainstream models predict, and that current global numbers are near historic highs. Her position has been sharply criticized by Derrisher Rode and Stephen Amstrup, former USGS Polar Bear Project leader and current chief scientist at Polar Bears International, who published a 2017 rebuttal in Bioscience, arguing that Crockford's analysis misrepresents population trend data and ignores projected ice loss trajectories. The disagreement is not about whether sea ice is declining. That is settled. The disagreement is about whether polar bear behavioral plasticity, the muskox hunting, the terrestrial foraging, the documented dietary shifts, constitutes genuine adaptation or metabolic triage. Calories from land prey, Derrisher's research suggests, do not replace the fat-dense caloric load of ringed seals. A bear eating geese and berries is not a bear preparing to survive an Arctic winter. It may be a bear slowing down how fast it starves. The genetics add another layer. A 2022 study in Nature Communications, led by researchers at the University of Copenhagen, analyzed ancient polar bear DNA and found that the species survived previous warm periods in glacial refugia, pockets of cold ocean that persisted when surrounding ice vanished. Whether such refugia will exist in a 2100 Arctic remains, in the study author's own words, deeply uncertain. We came into this with a simple question: are polar bears disappearing? We leave with something more precise and more uncomfortable. Some populations are declining, some are stable, nearly half are unmeasured. One subpopulation has found a temporary buffer that may not last a decade. Another lost 40% of its numbers in 4 years and has not recovered. The bears are not failing to adapt. They are adapting, documenting new prey, new behaviors, new tolerances that no biologist predicted. What remains genuinely open is whether adaptation at the behavioral level can outrun loss at the ecological level. Whether a species that evolved over 150,000 years in one of the most stable environments on Earth can restructure itself fast enough to survive the speed of what is happening now. The ancient DNA tells us polar bears outlasted warming before, but that warming unfolded over millennia. This one is unfolding over decades. Here is the question the researchers themselves keep returning to. If a subpopulation goes locally extinct before the ice stabilizes, can it recolonize, or is a polar bear population, once gone, simply gone? There is another species whose disappearance was once considered impossible, right up until the numbers stopped lying.